We're very excited to be introducing at this show TERS probes for tip-enhanced Raman spectroscopy. It's really something that the TERS community has recognized as a missing element, as a game changer when it becomes available commercially as a reliable probe. What we're standing in front of here is the Research AFM, the system that this probe will plug into. It's the Innova Research AFM. It's a high-resolution AFM, an AFM that does atomic resolution routinely. It also has a very optically open head, so that it can connect with large numerical aperture into a Research Raman system, and that's what's happening here. It's connected to a Renishaw NVIDIA Raman system. It's connected in hardware and in software, and really, in a sense, the missing elements so far have been probes. The kind of people that have been successful in this field really have been essentially people who are pioneers, who are able to build their own. So we want to make this capability much more widely accessible, allow users to combine AFM with Raman, do TERS, get the benefit of the nanoscale spectroscopy, nanoscale chemistry, without having to build your own solution. It's really part of our strategic drive, actually, to provide more information at the nanoscale. So on these probes, these are high contrast proven TERS probes. By high contrast, what I mean is that when you look at tip in, tip out, you get a high empirical signal contrast. That means a high near field enhancement. And that really means ultimately high spatial resolution, sensitivity, and clean spectroscopic signals. Now, tip-enhanced Raman is all about bringing the spectroscopy to the nanoscale, so high spatial resolution is an obvious need. High sensitivity is a need that comes with that. As you're looking at very few molecules at a time, you need to be very sensitive, very effective. And then you want to obtain the spectroscopic signals that you can understand, that the vibrational spectroscopy do with Raman, that you understand what the spectrum actually means. It's not a mixture of near and far field, of smaller and larger region together, but a clean near field signal. So that's why it's actually very important that these probes we are commercializing are high contrast probes. It's also important that they come with a test sample that we provide with a pack of probes. That's why we refer to them as high contrast proven probes. Allows a researcher for any one probe you take out of the package to use it on a known sample, on the sample we provided, to characterize it in detail, characterize that advanced probe before you put it on your unknown sample, and take that sort of guesswork out of the game, where you have a probe, you don't know it exactly, use an unknown sample, it gives you a lot of uncertainty, a lot of extra experimentation. Yeah, and so then these probes really are the element that you need together with the system to have a complete TERS solution. So actually very exciting to have taken this step now here at MRS.